3 algebra, we are going to talk about how to determine if two ratios or rates, they're all the same, form a proportion. And it's going to be important to know what a proportion is to determine if two rates or ratios form one. So, who can define a proportion? I guarantee you've used them before because we've done ratios and rates before, right? When we were talking about back in ratios, the dogs and cats in a pet store, right? And it was something like 24 dogs to 32 cats, and we wrote that as the ratio in simplest form of something like 3 to 4, okay? That's a proportion, right? 24 to 32 is the same as 3 to 4, okay? They're proportional. So define for me, what's a proportion? All right, give it to you. A proportion is equivalent ratios, rates, or what we're going to kind of focus mostly on today, fractions. Like I said, you've used these before. When you started to simplify fractions back in 4th grade, you were using proportions, okay? When we did our unit rate in PO30, those were proportions too, just a very special kind, right? Because it broke it down to 1, right? So a proportion is any set of the equivalent ratios, rates, or fractions. So the same way that you've determined whether or not two fractions are equivalent in the past, same methods we're going to use today, only now we get to call those equivalent fractions of proportion, right? So we're going to talk about 5 of them. Notice these are all key points, which means they can all go on a help sheet for you for the next test. And I'm going to scroll down so we can get as many of them on the page as we can. We'll do the first 3 and then we'll go. Okay, so one way to prove the following is a proportion. In fact, take a look at this. 3/4 is equal to 9/12. How would you prove that? I'll throw it out to you here, since you're so talkative. Share. How would you prove to me that's a proportion? Yeah.
Multiply them both by 3.
Okay, so we can use scale factor. Scale factor with multiplication. Okay? Method number 1 to decide or prove or determine if two fractions are proportional is scale factor with multiplication. And what that means is, what Penelope said is that we can take that 4, we can multiply by 3 to get 12, and we take that 3, multiply it by 3, and that gives us 9. Right? And because that scale factor is the same, we know they're equivalent fractions. Because they're equivalent fractions, we now know we can call it a proportion. How else could you prove to me, using scale factor again, that these are proportional? Gregory?
Divide 9 and 12 by 3.
Okay, so we can also go the other way with scale factor and say we're using scale factor with division. Because yes, 3 times 3 gives us 9 and 4 times 3 gives us 12. Well, if we go the other way, if we divide 9 by 3, we get 3. And if we divide 12 by 4, we also get 3, right? So that scale factor method works both ways. Sometimes it'll be more advantageous for you to go multiplication. Sometimes it'll be more advantageous for you to go with division. But just know they both work. Okay. Good. Question so far? Okay. I'm actually going to scroll down now, so I don't have to reach so far down the board to write. As you know, I'm playing hurt today. I was questionable for the day, but I'm powering through. So with 3/6 and 4/8, there's no scale factor that works very cleanly here. Nothing I can think of off the top of my head to multiply 3 to get 4 and 6 to get 8. So what's another method? How could you prove to me that these two fractions are equivalent? Anthony?
They can both be simplified to 1/2.
It's like you're in my head, children. This is perfect. Yeah. You could use simplifying to determine whether or not they are proportional. Because if we simplify 3/6, put it in the simplest form, what do we get? What's 3/6 in simplest form? 1/2. Okay? 3 out of 6 is the same thing as 1 out of 2. And then 4/8 in simplest form is also 1/2. And as we know, 1/2 is obviously equal to 1/2. Okay? And so when scale factor doesn't work, there are other methods to use. One of them is simplified. All right? The next one, 15/25 and 114/190. Ugh. When fractions get a little bit out of our comfort zone, like 3/6, 4/8, those are comfortable, right? They're easy fractions. We can tell they're 1/2. Simplifying is you can probably do in your head, but these two maybe not so much. So does anybody think back to last year, maybe in 5th grade, any other methods that you've learned involving equivalent fractions that you could use? We've used one this year already, actually, with percentages that you could use to determine whether or not these are proportional. It starts with a C. No, but that does start with C. Good job. Starts with a C, ends in cross products.
Cross product.
Well done, sir. Cross products. Cross products. Okay? And I want you to star this one because scale factor, sometimes it works well, sometimes the numbers aren't very friendly. Simplifying fractions, sometimes they're easy mental fractions, sometimes they aren't. Cross products will always work. Always work. Okay? And it's pretty easy to do regardless of what the numbers are. I'll do cross products with the friendly fractions up above here, just so maybe you can kind of see it a little bit more clearly. But what cross products tells us to do is that if these are proportional, if we multiply using the cross products method, then 3 times 8 will be equal to 6 times 4. Okay? If they are proportional, using cross products, the two products that we get, 3 times 8 and 6 times 4, will be the same. That's how we can prove another way that 3/6 is equal to 4/8. If I had two fractions that weren't equivalent, let's use 3/6 and say 5/9, right? Using cross products, is 3 times 9 equal to 6 times 5? No. 27 is not equal to 30. That means that all the way back up here, these are not equivalent fractions. They're not proportional. Okay? So if cross products works out, proportional. If it doesn't work out, not proportional. Pretty easy to do. And like I said, regardless of the numbers that you have, it will always work. So in this case, 15 times 190, yes, you'll need a calculator for it, but that's okay. $15 times 190, is that equal to 25 times 114?
Yes.
What is 15 times 190?
2,850.
2,850. And I'm guessing that 25 times 114 is also 2,850. Okay? So star that one. Like I said, we've already used it once to solve for a part, whole, a percent. Remember doing that? PO 2026, I believe it was. We've used it before. Here it comes up again. Cross products is very, very applicable. All right, one more method. We could use cross products on this because it always works, but if two fractions are equivalent, what will also be equivalent? If two fractions are equivalent, let's say 3/6 and 4/8, we'll go back up to that one again because it's nice and friendly. How could we rewrite 3/6 and 4/8 to show that they are equivalent another way? Yeah?
How many denominators?
With common denominators, we could do that. Not where I'm headed here, but that would work. What's another way to write a fraction? All the way back to CO2.
Oh,
Yeah.
mixed number.
If it could be, we could convert it to a mixed number. 3/6 though, can't really do that there. Yeah? Rational number. Okay. Starts with the D. Decimal. Okay, decimal. 3/6 as a decimal is 0.5, right? Half. 4/8 as a decimal is also 0.5, half. Okay, we can compare decimal values to see if they are equivalent. So in your calculator, go ahead and take 8 divided by 7. Remember that fraction just means a division. Okay? 8 divided by 7. What do we get?
1.14.
1.14. 1.14.
2,
8,
5,
5, 7,
143.
143. Okay? Not very pretty, but there it is. Right? Go ahead and now divide 28 by 24.5. And I'm willing to bet you're going to see the same kind of nasty decimal that you saw for 8 divided by 7, right?
Yeah.
1.142857143. Because those decimals are the same, they are proportional. If you were to multiply 8 by 24.5, going back to cross products there, it'd be 196. 7 times 28 is also 196. Cross products would work also. Scale factor, nah, kind of nasty. Simplifying fractions, not too helpful either. So cross products or comparing decimals would be the way to go. Okay? Questions on any of these 5? Yeah. What's that? Oh, sorry. Thank you. Comparing decimal values. Comparing decimal values. Okay. Any of these 5 that you've never seen before? Or never realized that you could do it? Decimal one? Yeah, that becomes a fan favorite eventually. When you start to get just really, nasty proportions that even cross products, even though it works every time, there's just other stuff going on. It's a nice, quick, easy way to compare. Okay? All right, second page. Notice that the 5 examples on the first page all have equal signs. I told you they were proportional, right? We just had to figure out how to prove it. On the second page, there are equal signs. Okay, I want you to determine whether or not 4/5 is proportional to 20/25. And I want you to do it using 2 of the methods discussed on the first page, and I want you to show your work. Okay, you can move around, or not move around. You can change methods. If you want to start with simplifying, because it's easy to simplify, you want to start with cross products because you like that one, or whatever you want to do, you can change them up, but you need to do 2 of them, and you need to show your work. So, for 4/5 and 20/25, what is one way that you can determine whether or not these 2 values are proportional? What do you want to use? Yeah. Simplify them. 4/5 is already in simplest form. Okay, so 4/5 is already in simplest form. What is 20/25 simplified to be? What does 20/25 simplify to be? If you made me walk all the way over
I did the decimal.
Okay, we'll use that one next. But someone answer my question, please.
Oh, I see what you
Penelope. 4/5, right? If you divide both 20 and 5 by 5, you get 4/5, and of course 4/5 is equal to itself. And so by simplifying, we've proven they are proportional. we get the same thing. Peyton went ahead and used comparing decimals, right? He divided 4 by 5, and Peyton, what'd you get?
Which one are we on?
4/5 when you divided 4 by 5. Didn't you use the decimal value?
I just put they were equal. I just thought they were equal.
Well, you have to show your work, right? That's part of the directions here, okay?
Well,
So you need to show me how you got that decimal. And so what decimal did you get?
Will not redo it. So
Yes. I need to see the decimal.
0.8.
0.8, okay? And then when you take 20 divided by 25, what do you get?
0.8.
0.8. Okay? And the reason why I'm requiring you to show your work on this is because you can get the answer many different ways. When you're looking back on this for a homework check or a bell ringer or a help sheet or whatever, you need to be able to see what you did, right? Just putting yes tells you nothing, right? Other than they're proportional. How'd you get there? That's the important piece here, okay? Let's do 5/30ths and 14/84ths. 5/30ths, 14/84ths. Give me one method that you'd like to try.
Cross product.
Cross products. Good old CP. Okay? So using that, we're taking 5 times 84 and 30 times 14. And we're seeing if they are equal. Looks like 30.114. I should make my decimal a little bit neater, or my multiplication sign. 30 times 14. There you go. What is 5 times 84?
$420.
420. What is 30 times 14? 420. Are they proportional?
Yes.
Yes, because they equal the same thing. Okay? You need to prove it using a second way now also. So we're not done with that one yet. Prove it using a second way. Any questions on what I'm asking you to do for these 6? You can use the same methods every single time. You can switch them up. I don't really care, but you must show your work. So even if you're comparing decimal values, I need to see what you're putting into your calculator.
So we don't have to do the last thing.
Yes, you do. We're going to talk about those now. Any questions on these 6, though? Okay, the last 3. You get to set up and solve your own proportion. It says a juice recipe requires 5 cups of orange juice for every 2 cups of water. Look at this. 5 cups orange juice for every 2 cups water. 5 orange for every 2 water. Right? That's our rate. That's our ratio. Okay, remember, ratios can be written as fractions. If you're using cross products to solve these, a fraction is a good way to write it. Right? Written in fraction form here. To make the recipe for a group at summer camp, the counselor is going to need more than just 5 cups of orange juice and 2 cups of water, right? So he mixes 45 cups of orange juice with 30 cups of water. Okay? The big question, will the juice taste the same? Did this counselor mix it proportionally? Will these taste the same? Are these 2 rates proportional? Why not, Anthony?
They can't be simplified by the same group.
Okay, so if you did simplify 35 or 45 over 30, what do you get? 9/6. Go a little bit further. Mia?
1.5.
Well, that's going all the way down. Remember, in a fraction, it shouldn't have a decimal in it. But if we have 9/6, what does that simplify down to be? And what's 1/2? 1 and 1/2 is a fraction in simplest form. Doesn't 9/6 equal 3/2? Okay. Is it 3/2 the same as 5/2? No. Right? If we use scale factor here, what did you multiply 5 by to get to 45? 9. If you did the same thing here, how many cups of water should there be? If you multiply the cups of orange juice by 9 to get 45, to keep it proportional, you do the same thing to the water. How many cups should there be? 18. There are not. There are 30. So, will it taste the same as the original recipe? It will not, because they're not proportional. Okay? Not taste the same. What will be different? If they were proportional, this should be 18 cups. It's not. It's 30. So is this going to taste more orangey, or is it going to be more watery? Gregory? More watery, right? He added more cups of water than he should have to make it taste the same. Because that number of cups of water is higher, okay, it's going to be more watery. Right? So, you need to do the 2 questions that we didn't talk about and the review. Basically, the entire second page is homework for tomorrow. Questions, comments, concerns, complaints, comments. I hope not. It's time to go. So long, folks.